Welcome back to Math 25. We're on Thursday of week 6. We're going to do starting the random problem for saving for retirement number 4 with compound interest that has both a monthly and a weekly to see the difference before them as a review problem. Before that, two quick announcements. One is that, as promised, when you go to the online lecture notes, at the bottom there's a new midterm for the personal finance decisions section. So if you want to take that at home, send me photos of your scratch paper, and then I will see if you get 70% or more for that achievement star. Somebody sent me an email wanting a reminder on how the achievements worked. So let's pick somebody's name and hit go. And then you can scroll down and see which stars you have. This person was wondering about homework in particular, so you can see which homework stars are checked off and which ones need to be turned in. If you haven't done a certain homework yet, then there's one link that takes you right to the turn in homework page where you would put in your answers, and another link of the discussion lecture notes for that topic. So you can study and see what you need to do. So this person is pretty much caught up, but patterns never got turned in and they skipped food prep. Saving for retirement doesn't have a due date yet. That one isn't late at all. Okay, those are the two announcements. So let's look at number 4. I should write at the top, this is turn in homework. For saving for retirement. Okay. This problem is designed to be slightly tricky because it has two parts. There's a part A where he starts with $6,000, 18 years, 4% annual interest, and compounded monthly. Part B, he is going to move all the money he has, so we can't know what the principal is to start part B until we finished part A. Then there's 37 years, 3% annual interest, and it's compounded weekly. So we'll do one at a time. There's a reminder that 18 and 37 is 55, but we are not going to actually use the 55 in the problem. Okay, we can get our compound interest formula. There you go. Nice to have that in front of us. And as before, I advise you when doing this to sort of organize your work off to the side. Before you just jump and plug things in, then it's nice to sort of do all the fiddling because that's where the tricky things happen. So I'm going to write all 4 things I will use. and get them organized first. So the final amount is what we're solving for. Actually, to save time, I'm going to grab that and put it over there. Okay, the principal, we're starting with the 6,000. So far, it's nice and simple, but now the trickiness starts happening. The rate per payout is 0.04 per year. I'm using RipLop on the 4%. And annual interest means that every year there's 4%. Fortunately, Sir Topham Hatt doesn't pay that much each month. When he gets his monthly bank statement, he only has to pay 1/12 of that. So because it's compounded monthly, we're going to divide that into 12 portions. So 0.04 divided by 12, 0.003 repeating. Now we have a per month, how much he's actually charged on his monthly bank statement. Similarly, the number of payouts, it sits there for 18 years. And he gets a monthly bank statement much more than 18 times, because every year he gets 12 of them. So we'll multiply it by 12 months. How many times does he get an envelope in the mail? 18 times 12. 216 months. Okay, everyone okay with all the setting up on the side? That's kind of the meaty part of the problem there.
Yeah.
So now that I've done the prep, that green fiddling, plugging it in isn't hard at all. It's sort of just the calculator does the work. So the final amount is going to be that principal times the 1 plus the rate per payout, so put a 1 in front here. If I round it and don't have my 3's repeating on the calculator, I'll be a few dollars off at the end of 18 years. So try and punch in lots of 3's into your calculator. And then the exponent is 216. Maybe I should make that not overlap things. So what do I get? 6,000 times 1.00, lots of 3's, exponent key, 216 equals, so $12,311.85. Everyone okay with that? By the way, when you're doing the random problems, it has answer keys. Let's look at how it writes it. It reminds us we're going to use it twice with the part A and the part B. It reminds you of what the formula is in sort of a condensed one. And it doesn't tell you about the fidgets. It just tells you that we're going to plug things in. The way floating point decimal arithmetic works for computers, sometimes it rounds funny. So don't worry too much about that. Anyway, so we're done with part A. And when we move on to part B, it will be similar. still have our compound interest formula. The number that we ended up with is going to be what part of this problem?
Will it be our principal?
Yeah, it's the principal. That's what we're starting out with. So our rate per payout is 0.03 per year. And the number of payouts is 37 years. And although those are true, that's not what we want. By the way, I have taken that 3% and changed it to 0.03 before moving down here. So now we have compounded weekly. What fidgets am I going to do to fix the per year amounts?
For some reason, I'm wanting to do months. I'm wanting to do the 365.
365 would be daily.
52.
52 is for weeks. There's 52 weeks in a year. So he has to do a divided by 52 and a times 52. Just like in the previous slide, there was a divided by and a 12. And this one might seem a little less natural because we're used to, in real life, getting a monthly letter from the bank with our bank statement. So saying that we're sharing the 4% with a little bit of that interest happening each month makes sense to us. And saying how many times does he get something in the mailbox, 18 times 12, because each year he gets 12 of them, that makes sense. There are very few things that in real life are compounded weekly, but it does exist, but they don't tend to get you mail. So this is just a little farther from our real life experience of we're not used to sharing interest among 52 things. We're not used to taking 37 years and counting how many weeks are in 37 years. But you can imagine it happens. The math is exactly the same. It's just a 52 instead of a 12 because a year has 52 weeks. Oops. Okay, if I do 0.03 divided by 52, I'm going to get some ridiculously small decimal. So I'm actually not going to do that. For the 37 times 52, then I get 1,924. So that's how many payouts happen. What I'm going to do, instead of having a ridiculously small decimal that I am too tempted to round in the middle, and that would make a mistake, I'll just put 0.03 divided by 52 there. If you want to do the decimal to make it look exactly like the previous problem, you can. But just to be a little more accurate, I'm going to go ahead and use these parentheses that I otherwise could leave out. So I'm actually doing this part. Last time I didn't. I just said what is 0.04 divided by 12, and I put the 1 in front of it, and all of that was sort of built into one number. But now I'm not, so that no rounding happens here. The calculator knows the order of operations. It will do the division before the addition. So everything is easy to do in the calculator still. We know how to use our parentheses keys. So what does this turn out to be? getting 37,346.61. Are your calculators getting the same? Do you need calculator help, Donna?
I'm still trying to get the right one. I'm trying to figure out what I did wrong.
Okay, keep trying. I'm going to go, assuming you have it on your paper in front of you, look again at just how it is written over here. So the old answer became our principal. This tries to put in that long thing that I was avoiding having on the slide, and it gets the same answer. Oh, I should close that.
Got it. Thanks for your patience, guys.
No problem. Did it work for you yet? If not, I'll write out all the key presses. You got it?
I got it.
Okay. Did that answer your question before we started the recording about the difference between monthly and weekly and how the monthly works and things?
Yes, that helped a lot. Thanks.
Okay. Should we do any other of these random problems? Anything on the board look like I should do it as more review?
Do 5. We should do 1 or 5.
Okay, if you didn't pick 5, I was going to pick 5, so. Great minds think alike. So this problem is kind of similar and kind of different. It still has 2 parts, so I'm still going to want to start this on 2 slides. In part A, she has 14 years go by, and she deposits $1,270, but now it happens each year. She's making repeated deposits. She's not just depositing the money once and watching what happens. It has 7% annual interest, and it doesn't say compounded monthly or compounded weekly or anything. So the default, when it doesn't tell us, is that it's annual compounding, which we like, because that means we don't have to do any fidgeting with 12s or 52s. Everything is in years, and it just stays there. For part B, she stops making deposits. Now she's just going to watch what happens. And it's 7% annual interest and 36 years. So how do we start this one? What do we do when she's making deposits each year?
Sum of annuity due.
Yes, different formula, not compound interest, but the one called sum of annuity due. And just to refresh your memory, this formula looks longer, but it's actually nicer because we never do it with anything other than plain old annual payouts. So it never uses the weird divided by 2, divided by 12 times 12, or divided by 52 times 52. So I'm not going to bother with all of this stuff on the side. Since I don't have the awkward fidgets happening, then I don't need to be this careful. This was a good thing to do for compound interest with monthly or weekly payouts, but I don't need to do that much being careful here. So the principal is 1,270. 1 plus the rate. Let's see, let me space things out a little bit. So 1 plus the rate is 1.07. 7% is 0.07. Now I'm going to multiply again, and these brackets that look kind of big are just parentheses. That's a weird pen. Let's do that one. That's just sort of typewriter talk for bigger parentheses. So I'm just going to write them as bigger parentheses. The 1 plus rate, I don't need the inside parentheses. That's just a 1.07 again. The years is 14. Okay, I'm going to line things up a little better. Since I have more room on this slide, I am going to go ahead and write out what I would put in my calculator. So I would put 1270, then I would hit the multiply key, 1.07, then I would multiply, then I would start my parentheses, then I would do 1.07, then I have a key that either looks like y to the x, or it might look like the caret symbol, kind of like a mountain. And then I would have 14, subtract 1. Then one big mistake is forgetting to close your parentheses. Lots of people do that. Then I have divided by, and I probably wouldn't actually type the 0. And then I have equal. The other big mistake is that there's no 1 here. We are so used to putting the 1 in twice that sometimes without thinking about it, we try and put a 1 there, but there isn't. There's no 1 plus for that rate. So that's what you'd actually put into your calculator. And what do we get? I'm getting 30,643. Is that what other people also got on their calculators? So once again, because she deposited the same amount every year repeatedly, we use the sum of annuity due formula. Now we're done with that. Actually, I'm going to grab that before I box it. Okay, what formula do we use on this slide?
Sum of annuity due.
No, it's not sum of annuity due. She's stopped making more deposits.
It's a compound.
She's just taking the amount from last time and watching it.
Compound.
Yeah, I heard you faintly. So this is compound interest again, same as Sir Topham Hatt was doing earlier.
Compound.
There's just one thing, and we're just watching it grow. This is how we like the compound interest to be. Since it's annual compounding, the formula looks very friendly. It is great when there's none of the funny stuff with weekly compounding or monthly compounding. Unfortunately, real life almost always has monthly compounding. Okay, once again, the calculator does all the work. Did I press my buttons right? Everyone get the same answer? Okay, let's look at how it appears here. So first it says we use the sum of annuity due formula, but it doesn't actually write it out. It just gives you the answer. And then we use the compound interest formula and get that thing. So not as helpful an answer, but at least you can check your work. The other one I expect we should do is number 2. Should we do number 2 for more review?
Yes.
Let me know if you can hear my son's musical instrument practice, and I'll tell him not to do it now. Can you hear that in the microphone?
Barely, it's not even really
No.
noticeable.
He's going to get louder. Okay, let me pause the recording and tell him wrong time. Okay, thank you for your patience. There is no longer a baritone horn in the house being played. Okay, so the two examples we've done earlier were sort of straightforward problems that we're plugging things in and it's spitting out something on the left-hand side of the equal sign. That's sort of how we want formulas to work as a machine. We plug things in the right-hand side and then it spits them out on the left-hand side. What makes number 2 tricky is that we are told the wrong things for the formula to work in that kind of machine where we plug things in on the right and it spits out the answer on the left. Here we have to be a little more creative. So because there is weird stuff happening, I'm going to go back to my habit of writing everything out first before I try and plug things in. And that way, whatever is tricky, I will notice before I get started. So in this case, the principle is easy to see, 1,164. Instead of years, we're given 37 days. There's a post-dated check for a little bit more money. So I'm going to say for the interest, she is paying back the loan, and she's also paying a little bit more to cover the interest. So the difference must be the interest. That doesn't look like a 4. There we go. Everyone okay with finding the interest amount? I would talk more about post-dated checks, but I think we did that a couple days ago. The loan's simple interest rate, that's what we're trying to solve for. So if you've been wondering in the earlier problems, why did he bother to write out that the final amount is what we're solving for? That's kind of clear and obvious. That is just not always true. So I'm in the habit of putting final amount just to make sure that really I'm solving for the right thing. Okay, we need to fidget with with years because somebody gave us days. So I want to make this some amount of a year. How will I do that?
Is this where we use the 365?
Yeah, so that's out of 365 days. So it's that fraction of a year. I'm going to write in 2 colors because I don't know if that's the clearest to just do it all. So now I have done all of my adjustments and I'm ready to plug things in. So I'm used to a formula that looks more like 3 times y equals 12, And then I can say there's something stuck onto y with times 3. The opposite is going to be divided by 3. If I do it to one side, I have to do it to the other. That gets y by itself, and 12 divided by 3 is 4. So that's the kind of thinking I'm wanting. I want my letter times other stuff. So here, my letter is stuck in the middle. But that's not a problem. It doesn't matter what order I multiply two things. So I can switch these. I'm also going to know that how do I make a fraction something easy to put in my calculator? I go top divided by bottom. So now I have this thing that I like. There's something multiplied by my letter. And my something, whoops, that's not a highlight. Looks complicated, but it's just one number. So now we have two different styles. Some people want to take that thing and write a single number here before we move on. Other people are going to say, I don't need to know what that number is. I'm going to jump right away to say, I'll divide it by parentheses 1164 times 37 divided by 365. So you pick. Do you want to do a divided by 3 things in parentheses, or do you want to first make this just one number so it looks nicer?
I'm sorry, David, I had a child make a noise.
That's okay. Should I repeat the question?
Yes, please.
Okay. So all that stuff highlighted in blue turns into one number. So we just have an aesthetic choice now. How do we write it? Are we going to take that and make it one number? So we have something that looks very nice. Or are we going to say, I don't need to know what that number is. I can just take both sides and divide by all of it. They're both good ways to do things. Which one makes more sense to you? No preference?
I'm sorry, he's still.
Yeah. How about I just do it both, actually? So I'll just grab everything. Put it on the next slide. Okay, so one way to do things is to say, let's find out what that number is. So 1164 times 37 divided by 365. That number is 117,9945, and so on. So now we have something that looks very much like this. Something is stuck onto our letter with multiply. So let's divide both sides by that to get the letter by itself. Now the letter is by itself, and what is that? So 3068 divided by previous answer, 0.26. We're not quite done. What's our very last step?
Do we have to take it out of percent?
I couldn't hear you, cut out.
Do we have to change it from percent notation?
Yes. So it asked for a simple interest rate. We want it in percent format. So 26%. Any questions about the way it's written this time? Okay, so some people, as I was saying, think this is too much writing. They say, I don't care what 117.9945 really is. I'm just going to say whatever it is, I can divide by it because it's a number. So we'll divide this side by the 1164 times 37 divided by 365, and that will get rid of it. And so for the $30.68, we also have to divide by all of 1164 times 37 divided by 365. And if you plug in your calculator 30.68 divided by parentheses all of that, then you would get the 0.26 with less writing on the board. So some people like this style better because you write a little bit less. Other people like this style better because this line looks very much like what you're used to. Number equals letter times other amount. Okay, that was from the random problems. This is a forward direction of simple interest. That's pretty easy. Should we do number 3? I'm surprised no one has asked about that yet.
Let's go for it.
Oh, okay. The tricky part about number 3 is it doesn't tell us the principal. And that's not a problem because the way this kind of problem works, you can just make up anything you want. So I'm going to just pretend the principal is $100 because 100 is a nice number for percentages, right? 3% of 100 is 3. So what we then have is he has $100. It goes up by 14%. So how much will he have at the end of the year?
114.
114, right? That's why I picked 100, so the numbers would work out so nice. So then it goes down, and I don't know what percent this is. And it comes back to 100. Is my unknown amount going to be bigger or smaller than 14?
Smaller?
Smaller. This is going to be slightly smaller than 14. Let's talk about why. If his peak value was 100, then 14% would bring us down $14. And we want to go down $14. But his peak value is bigger than 100. So if we do 14% of a bigger number, we're going to get something a little more than $14. And then we're going to come back down and we'll be at $99 or $98 or something like that. The same percent of a bigger number would be a bigger change. Just like 14% of Bill Gates's income is a lot bigger than 14% of my income. Same percent of a bigger number is bigger. So since the peak amount he has is bigger, we need a slightly smaller percentage to compensate so that we still go down exactly $14. Otherwise, we're going to kind of overshoot. So we've done lots with percent sentences. What we're actually asking is $14 is what percent of the 114? Everyone see why this is our question? I want a positive 14 here, and I want a negative 14 here. So we need to ask ourselves, this 14 going down is what percentage of the 114 we're starting with? Because for part 2, we're starting here and then moving down from it. So we know how to do these. We translate things. There is also a proportion method if you liked that. Numbers stay the same. Is becomes equals, I don't know what the percent is, of becomes times, numbers stay the same. Something is stuck onto y with times 114, so I'll do divided by 114. Now y is by itself. What is that? 14 divided by 114 gives me 0.1228. So I'm going to change this into a percent. Should I say 12.28%? I don't care too much about how you round. If you wanted to say 12%, that would work. 12.3, that would work. 12.28, that would work. The rounding isn't the important part here. So this is a unfortunate lesson about investing. For his money to go up, there had to be a 14% improvement, right? The economy was doing well, whatever was happening, good news was happening in his investing. To come back to where he started, he only needed about 12% of bad news. Because the higher amount meant that the same change was a lower percentage. So this is one reason as we get older, we move into bonds and more conservative investments. Because when you're young, you have lots of time to say, oh, things are going to get better. But once you've saved up some money, then a smaller amount of economic bad news will undo your progress, just because of how percentages work. Okay, now I'll finally trust that we've done enough of the random problems. As before, if you go to the practice tests, then the personal finance decisions midterm, you can do as many of these as you want, see the answers, and all this is the random homework problems from these sections put together. So we don't have to do extra work for doing some practice midterm problems. So do these as much as you want by yourself. In this section, you're aiming for about 10 out of 12 that you can do in a nice quick way. There's no time limit in spring term 2020, but still pick the efficient problems. And then when you think you're good at that, if you want to have me grade it, because sometimes it's fun to not grade yourself, then you can go here and it's exactly the same thing, except I have the answer key on my computer and you don't. Don't send me one that you've generated randomly, because then I won't have the answer key and I'll have to do all the work long and I don't want to spend that much time grading. So if you want to try and do one to get the check mark for I've done a midterm with 70% or more, please do this one in the lecture notes page. Don't do a random one. Otherwise, I'll just send it back to you and say, no, that's your grading job, not mine. And as a reminder, if you go to the achievements and search for midterm, then there's just a check mark for 70% or more. It doesn't matter whether you get 70% or 100%. If you get 70 or more, then you get this check mark, and that helps you with things. There's also only one of them. So if you were to do both midterms, right, whoops, that's math 20, both the health one and the personal finance, then yeah, go ahead and practice. But if you've done one, you have the check mark. And lastly, there is two different stars you get for having neatly written problems. And you probably have this already for your topic homeworks. You've sent in codes to me, but you have some scratch paper where things were written out neatly, and you just need to take a picture of it and send it to me. If you've never done that, then the midterms are a great way to say, look, I have written out 16 problems neatly. You're sending them to me anyway. So you can actually get 2 stars from a midterm if you don't have these already from sending me your homeworks. I don't want to see the scratch work for every homework, just enough to affirm to other teachers or employers that, yes, you know how to write things out neatly. And if you're in a group project, no one is going to say, what? I don't understand all this stuff on the page. Okay, saving for retirement problems to turn in. We've done a lot of these, but not all of them. And some of them on purpose I have given you a sort of hint or head start on, but not done all of them. Are there one of these that you want me to do out in its entirety?
Look at number 7.
Number 7. Let's do number 7. Did I say turn in at the beginning? Yes, one moment, let me
I
fix it.
hope.
So we're about to do the turn in homework for saving for retirement, but before it was the random. No one caught me and corrected me. Okay. So for number 7, I'll keep that tab up. It may help me. Oh, no, that one I don't need. Oh, okay. Turn in problems. What happened? Why is all this here? You go away. Why did everything come out? Very strange. Okay. Okay, so annual compound interest. We're back to the very friendly version of compound interest that we like. Everyone get about 121,000? I didn't make any calculator button mistakes.
I got this.
Okay, why are we picking these numbers? Who invests $3,865? Why 9% and why 40 years? And that's because somebody did some research, the company named Vanguard, and the average person in the US under age 25 has saved up $3,865 for retirement. 9% is the average stock market increase. Might not feel like it today, but that is what it averages historically. And if you're 25, you have 40 years until you're 65 and you retire. So if the average person about to turn 25 took their average savings and didn't touch it for 40 years, they would probably have about this much, because it wouldn't be exactly 9%. Vanguard also found out that when somebody gets to be 65, the average American has $176,696 saved up. That's a lot less than the 400,000 we talked about. That's sort of the typical American goal. So if we take this bar and we subtract away what they were starting with, then we get $55,298.59. And that number is sort of depressingly small. That means that all the time between age 25 and 65, people just don't save very much. They get some little nest egg when they're young, and watching that grow is pretty much the majority of what they have by the time they retire. So in a way, that's good news. It would be nice if people saved more, but this means that even if you can't become a great saver and have that goal of 400,000 when you turn age 65, then being an average American isn't terribly difficult. And we talked about that just cutting down on cigarettes and Dutch Brothers might get you well more than this overall. And average Americans aren't starving in the street when they're retired, so it works. It might not be the dream retirement with lots of golfing and vacations and so on, but it's a good enough retirement. So this is sort of a good news problem that yes, people have a little bit and they don't save much more, but it's a goal that's a much smaller goal, less than half of the 400,000. And it seems to be sufficient looking around at people who are older. Should we do number 8 together?
Sure.
The other way to think about this is if we were to use the sum of annuity due formula. There we go. Imagine somebody is trying to save up to have that average American nest egg at age 65, then what would they need to do? The final amount and I'm not going to write final amount actually, we know what it is. We want it to be 176,696. So it's going to be some principal we don't know, the 1.09, 1.09, 40 years, everyone okay with that? So this looks a lot like Joyce's post-dated card. There's a letter times a bunch of stuff. So I'm going to take all that stuff and just make it one number. So 1.09 times parentheses 1.09 exponent 40 minus 1 close parentheses divided by 0.09. I'm getting that all of that turns into 515.933 repeating. So now I have a number is my letter times a number. I can get my letter by itself. What is that? So 176,696 divided by previous answer key. That's not what I had expected. I thought it was more than 400. Did I do something wrong? Let's see. Yes, I did. I think my 515 is wrong. Did somebody get 368 more or less as a number?
Still do. I got like 6.5.
Does that look better, Timothy? There we go. So 479. So what this is saying is if every year for 40 years with typical stock market increases, if you saved 480 bucks, then by the time you're 65, you would have that average goal of the average American's retirement amount at 65. So can you scrounge up 500 a year, 480 a year to retire? Most people can if they look at their budgets. Not everybody, but most people. So aiming to be average isn't terribly hard. Assuming that you have the luxury of starting young. If you're 50, then it gets harder. Okay, we have 10 more minutes. I don't want to start the next topic, but let's do a kind of just overview then and see what we'll be getting into next week, because we're done with personal finance decisions. I expect that the saving for retirement homework will still have questions when I see you Tuesday. So I'm guessing this won't be due until at least next Thursday. So at the very end, we're doing business decisions. What kinds of things are we looking at? So first we have cost and price, and margin and markup. And these are words that have very specific meanings. And just so that you could either someday start some small business, because a lot of people take Math 25 because they're going to start a daycare or a food cart or some other things, then you'll know the vocabulary. Or if you just have friends or colleagues that are running a business, then you can talk about it, because most people use words like margin and markup and profit in a sort of sloppy and inaccurate way. We're going to talk about pricing and how much should you price things so that your business can do well. And there's different goals and math formulas about that. This is a sort of interesting chart to look at, that when you have a good that's newly invented, it's expensive to produce. And then as their technology matures, the wholesale cost decreases. And the phrase for that is penetration into society. And you can see how the curves are very different for different technologies. Telephones, this, by the way, is percent of US households going up and what year it is on the bottom. So when telephones were new, very few people could afford them. And it went up kind of slowly. During the Depression, it went down. And then once we sort of hit World War II, technology advanced quickly and lots of people got telephones. And now almost everyone does. Refrigerators, people wanted a lot more than phones. They started out, again, new and expensive, but they shot up pretty quickly. Everyone wanted a refrigerator. Other things like dishwashers might seem surprisingly slowly. That the demand for dishwashers didn't shoot them up to the percent of households having them nearly as fast as refrigerators, and so on. Internet, right? Cell phones, very steep. Microwaves, zoom. My family was like the last one to get a microwave when I was little. Okay, anyway, pricing. There's adaptive and dynamic pricing. So if you look at how Sears or Amazon or Best Buy price things during the day, it changes, because when people want to shop at certain hours, more people are shopping, so they can charge more. So Sears doesn't do that. Their numbers are always the same, but Amazon does that a lot. It bounces all around. We are going to have a whole section on how to price food, because there's a lot of culinary students taking Math 25. And then we talk about discounts. When you put things on sale, what are the math issues to think about? And then the next main topic is charge options. This is sort of a business thing of what kinds of charge options could your store use if you owned a store. But it's also sort of a personal finance thing. If you're trying to buy a dining room set and there's a layaway plan and an installment plan and a zero down plan and credit cards, what are the pros and cons of all of them? So we'll talk about that. And then we have likelihood. We're going to start by doing a little spinner game. If you have a toy with a spinner at home, then I'll give you a heads up to sort of get it ready for that class. If not, I'll use my webcam and just do examples with mine. And once we get a sense of some chance events, then we'll talk about probability and odds. And the simplest cases use dice. So what are the ways to get a sum of 7? You could get a 6 and a 1. You could get a 5 and a 2, and so on. What are the ways to get a 10? You could get a 6 and a 4, or a 5 and a 5, or a 4 and a 6, and so on. So we'll use tables like this to talk about probability a little. And we'll talk about the difference between probability and odds, which are other words that people use sloppy, even though they have a technical definition. And the main thing to talk about then is absolute change and relative change, because the how likely things are, less likely and as likely are phrases that are, again, sloppily used, and they matter a lot. So we'll talk about that, and this is partly so you can advertise things correctly, and partly so that you can notice as a consumer when there is a people are hoodwinking you. They're using the wrong measure of change to try and sell you something. And at the end, we'll talk about weighted average. And the classic thing for college students is I have a grade book, not like ours with stars, but a traditional one, where there's a certain percentage of the grade for different categories. So if you score a certain amount and it's worth a certain weight, then what's your overall grade? So that's called a weighted average. And we've already done mean and median. So this is the last kind of average to talk about. And then that's it. So it's not that long a section. If we started on Tuesday, we'll probably finish it in 3 sessions. And then we'll have a long time to review things. And if it takes longer, that's fine. We have time. Okay, any questions about that? No? Okay. Well, we're 3 minutes early, but I'll stop. Maybe see you Friday tomorrow for the study session at 3:30 if you want to do that. And otherwise, have a good weekend.
You too.
Thank you, David.